Okay, so let us say that I have a circle and I have a rectangle inside this. This is the center of the circle. Okay, and
Hello.
yes,
Hello. Sir, can you hear me?
yes, I can hear you.
Good afternoon, sir.
Good afternoon. So this is the center of the circle O, and the rectangle here is ABCD. Okay, this is your interior angle 90 degree of the rectangle. I need to show that when this rectangle has maximum area, then it must be a square. That is, length must be equal to breadth. Let us say that I take the length as x and the breadth as y. So I want to show that length must be equal to breadth. In case this rectangle has maximum area, okay, then how do I show? Now see here, first of all, I have considered the length as x and breadth as y. We first identify the maximizing function or the minimizing function. What is the maximizing function here? Maximizing function is area, right? Equal to x into y, length into breadth,
Yes, sir.
right? I need to maximize this function. Now, under what conditions? What is the auxiliary function? Auxiliary function. Now we will note that area has two variables, x and y. Okay, which makes it difficult for us to work with two variables. So what I'm going to do here is I'm going to remove either x or y from the maximizing function to make it into a single variable. With the help of what? With the help of this auxiliary function. Let us find out what this auxiliary function is. Now see that if you apply Pythagoras theorem in triangle ABC, you get AC square is equal to AB square plus BC square. That means you get x square plus y square, right? So that means what is AC?
Yes,
The
sir.
length of AC is square root of x square plus y square. So therefore, what should be the radius of the circle? Radius is half of AC, which is half root
Yes, sir.
x square plus y square, right? This is the radius r. Now this
Yes,
circle
sir.
is given to you, right? This circle is given to you, isn't it? So this, if this circle is given to you, then this circle
Yes,
must
sir.
have constant area if it is given. Only the rectangle length and breadth is variable, right? Why? Because you need to show that rectangle is a square. So you have to adjust your length and breadth such that the area of the rectangle is maximum. But the circle is given to you. That means the area of the circle is constant. So therefore, you calculate the area of the circle. Okay, what is the area of the circle here? Let us denote the area of the circle by say B. Let us call the area of the circle as B. Okay, or let us call it as C. Area of the circle as C. So C is a constant. And what is the area of the circle in this case? Pi r square. And what is r here? Half root x square plus y square whole square. This is pi r square. Okay, so what you get here is C is equal to x square plus y square into pi by 4, right? So that means with the help of this now, I'm going to remove from the area, I'm going to remove one either x or y. Okay, so what you do here is you find x in terms of y from here. So you get 4c by pi is equal to x square plus y square. Therefore, what do you get? You get, say, y is equal to 4c by pi minus x square, y square. Therefore, y is what? Y is root over of 4c by pi minus x square. Okay. So got the value of y. Now from this value of y, we'll put it in the maximizing or the minimizing function. Okay. Therefore, what is the area? Therefore, area is equal to xy is equal to x root 4c by pi minus x square. This is the area. Now we have got area in terms of x only. Now we can differentiate. Okay. So how do you differentiate here?
Okay, sir.
Um, you differentiate it. Therefore, dA dx is use u into v rule x into ddx of 4c by pi minus x square. This is 1 by 2 root 4c by pi minus x square into a differentiation of whatever is there in the radical. Now 4c by pi is a constant. You get minus 2x. Okay. Then plus root over of 4c by pi minus x square into ddx of x, which is 1. Okay. So what are you essentially getting here? This 2 and this 2 cancel. So you are getting x square by root 4c by pi minus x square plus root 4c by pi minus x square. Okay. Now what would we like to do? We would like to take the LCM. LCM is root 4c by pi minus x square. So what will you get? X square plus 4c by pi minus x square. So what is happening here? Um, this is minus x square. This is minus because there is a minus sign here. Okay, so what is happening here? What are you getting here? There is also a minus sign here also. Okay. So you're getting minus 2x square plus 4c by pi divided by root 4c by pi minus x square. This is what you are getting. Okay. Now what happens for local maxima or minima? You must have dA dx is equal to 0, right? That means minus 2x square plus 4c by pi divided by root over of 4c by pi minus x square must be equal to 0. Then what is the value of x that you are getting here? That means you are getting minus 2x square plus 4c by pi is equal to 0. That means you are getting minus 2x square is equal to minus 4c by pi. That means x square you are getting minus 4c by minus 2 pi. Okay. So what are you getting here? Minus minus cancel. This cancels. You're getting what? 2c by pi. The value of x. That means what is the x square? So what is the value of x? It is square root of 2c by pi. Right? So at x is equal to 2c by pi, the area is either maximized or minimized. Okay. Now our next task is to find out the second derivative. Okay. So now we have d2a
Yes, sir.
dx2 is equal to, you differentiate this once again. Okay. So what do you get? You differentiate this by u by v rule. Okay. So if you differentiate this first, v root 4c by pi minus x square into the ddx of the numerator. What is the ddx of the numerator? Minus 2 into 2x, which is minus 4x, right? Plus 0.
Yes, sir.
Okay, because 4c by pi is constant. Next, minus u. Which one is u? minus this u is minus 2x square plus 4c by pi into the ddx of the denominator. And what is the derivative of the denominator? It is 1 by, it is minus 2x by 2 root 4c by pi minus x square. Okay, divided by, whole divided by root over of 4c by pi minus x square whole square. Right? Simple application of u by v rule. Now the question is, will it be positive or negative? That is the question. Now see here, if you simplify this, what do you get? Minus 4x root 4c by pi minus x square. And here, this minus, they combine to give you a plus. Again, there is a minus sign here. So this minus sign remains a minus sign. Okay. So if this remains, then what will happen? Here, you get minus 2x into 2x square plus 4c by pi. This, in fact, this 2 and this 2 will cancel here. Okay, so you simply get x divided by root over of 4c by pi minus x square, whole divided by 4c by pi minus x square. Okay. Now see, for what is the value of x that we need to check the value of d2a dx2 at x is equal to 2c root over of 2c by pi, right?
Yes, sir.
If you put it here, okay, you don't in fact even need to put it. If you put it here at x is equal to root 2c by pi, just by observation, can you tell me whether the second derivative will be positive or negative? See, this part will be negative, right? Because 2c by root over of 2c by pi is positive. This part will be what? This part will be negative, right? This part
Yes, sir.
minus of this part will be positive. That means the entire numerator is positive, right or wrong? We are only concerned with the sign. We don't need the value.
Yes, sir.
Okay. That means minus this negative
Yes,
minus
sir.
something positive will numerator will be negative. Look at the denominator. The denominator here is 4c by pi minus, now what is the value of x here? Root over of 2c by x whole square. So what are you getting actually? 4c by pi minus 2c by x square. Sorry, 2c by pi. 2c by pi. So what are you getting? 2c by pi. This is again positive. That means this entire fraction is what? Negative? Right or wrong?
Yes, sir.
Yes, sir.
Yes, sir.
That means this entire fraction is negative. That means d at x is equal to 2c by pi d2a dx2 is negative. That means at x is equal to root 2c by pi. A is maximized. A is maximum, right? Second derivative is negative. That means A is maximum.
Yes, sir.
So
Yes, sir.
we have got the length when the area is maximum. So how will I get the breadth when the area is maximum? From the auxiliary function here. See here, we have got y is equal to, see, we have got y is equal to 4c by pi minus x square. Put it here. Therefore, y is equal to root over of 4c by pi minus x. What is the value of x? 2c by pi whole square. Right? So what are you getting?
Yes,
This
sir.
is root over of 4c by pi minus 2c by pi, which is root over of 2c by pi. See, what are you getting? You're getting length is equal to 2c by pi, and you're getting breadth is also equal to 2c by pi, right? So therefore, since x is equal to y is equal to root 2c by pi, therefore ABCD must be a square, right? Or is this clear or not?
Yes, sir.
See, in the example, they have done a different approach here. In the example, they have done with the help of angles. Okay, I have given you a different approach here. If you go by the example is actually a higher technique. Okay, once you are
Yes, sir.
more acquainted with this, this example solution is a higher technique. But the technique that I have told you, although the calculation is a little more, but this is a more this technique will appeal more for starters, because you're not taking any angle as theta, you're not taking any sine function. Okay, you are simply using length and breadth as your variables, and you are showing that when area is maximum, length is equal to breadth. Okay,
Yes, sir.
so that is one problem.
Yes,
Next
sir.
problem, number
Okay,
28,
sir.
I would like to work out. A right angle triangle ABC with constant area S. So area of the triangle is given to be constant. Okay. Prove that the hypotenuse of a triangle is least. That means which is the maximizing function here? The length of the hypotenuse is the minimizing function, in fact, because they are saying least, right? So length of the hypotenuse is the minimizing function. When the triangle is isosceles, okay, you need to show that this triangle is isosceles. That means you need to show that apart from the hypotenuse, the two lengths are equal. That is what you want to show. Okay, that means if I want to show that if this is your right angle at B, okay, that means what do I want to show? I want to show that this, if I take this as x and this as y, then x must be equal to y when the hypotenuse is least. Okay, that means what is your maximizing function here? Minimizing function, in fact, not maximizing, because you're trying to find the least value of the hypotenuse. So minimizing function. Minimizing function is length of the hypotenuse. What is the length of the hypotenuse here? Right? By Pythagoras theorem, you can write L is equal to root over of x square plus y
Sir,
square.
x square plus y
But the
square.
problem here is that in the minimizing function, again, I have got two variables. So I will eliminate one variable with the help of what? Auxiliary function. So let's see what my auxiliary function is. It is given to you here that the right angle triangle has constant area, right? So S is equal to half of
Yes, sir.
xy, half base into height. That means S is constant here, where S is a constant,
Yes, sir.
right? So that means you can find y in terms of S. So y is equal to 2s by x, right? Now we
Yes,
can
sir.
put this in the minimizing function. Now L is equal to root over of x square plus y square, which is equal to root over of x square plus, and what is y? It is 2s by x. So now what do you see? Your minimizing function is only in terms of x. X square plus 4s square by x square, right? So when s is constant,
Yes, sir.
4s square is also constant. Now if you take the LCM here, you will get root over of x to the power of 4 plus 4s square divided by x square. That means this becomes root over of x square plus 4s square divided by x only, right? So now what to do? Govinda, tell me what to do.
Yes, sir. Hello. Hello.
Yes, tell me what to do after
Hello.
this. Tell me what to do after this. You
Sir,
have
after
found
this we will differentiate.
differentiate what with respect to what?
Sir, D, sir, with respect to X.
DL dx we will find, right?
Yes, sir. Yes, sir.
DL
Yes,
dx.
sir.
What is DL dx? Use U by V rule. Okay. U by
Yes, sir.
V.
U by V rule.
V ddx of this. What is the ddx of this? 1 by 2 root x square plus 2s square
Yes, sir.
into 2x, right? Because 2 x square plus 4s
Yes,
square.
sir.
Sorry,
Yes,
not
sir.
2. X square plus 4s square into 2x because 4s square is constant minus u, that means u is x square plus 4s square into ddx of x is 1. So that makes it divided by x square. So now you calculate this, you get this two cancels, and if you take the LCM in the numerator, what do you get? X square minus x square plus 4s square, right? This is what you get. Okay, so you're getting in the numerator, you're getting 2x to the power of 4 minus x to the power of 4 plus 4x square, and in the denominator you're getting x square root x to the power of 4 plus 4s square. Okay, this is what you're getting.
Yes, sir.
So you get x to the power of 4 minus 4s square divided by x square into root x to the power of 4 plus 4s square. Okay, so now what happens for local maxima or minima? For local maxima or minima, you have dl dx is equal to 0. That means x to the power of 4 minus 4s square divided by x square root x to the power of 4 plus 4s square must be equal to 0. That means what do you get here? X to the power of 4 minus 4s square is equal to 0. That means you get x to the power of 4 is equal to 4s square. Right? That means now you take the square root. This is x square square is equal to you get x square square is equal to 4s square. That means x square is equal to square root of 4s square, which is what? 2s, right? So you're getting x square is equal to 2s. Therefore, what is x? Square root of 2s. Right or wrong?
Yes,
Yes,
sir.
you can see and hear.
Yes, sir.
Can you see and hear everything?
Yes, sir. Yes, sir. Yes, sir.
Yes, sir.
Okay, so dl dx you have got this, we equated this to 0, and x is equal to root over of 2s. Either we have a maxima or a minima. Now how will you check whether it is a maxima or minima? We'll find out the second derivative. So we start from dl dx. One second. Therefore dl dx is what? X to the power of 4 minus 4s square divided by square root of x square into x to the power of 4 plus 4s. X to the power of 4 plus 4s square. Okay, this is what we have as dl dx. I want to find out the second derivative of this. How do you find out the second derivative of this? How do you find? You can use u by v rule.
Yes.
But before using u by v rule, what you do is this x square, you take it inside this radical. Then what will happen? If this x square, you take it inside this radical, this will become what? X square square. It will become x to the power of 4. And x to the power of 4 into x to the power of 4 is x to the power of 8 plus. And this will become 4x to the power of 4 s square. Now this will be a little easier to differentiate. So therefore d2l dx2 is x to the power of 8 plus 4 x to the power of 4. Don't be afraid by your differentiation. Okay, you just need the sign of d2l dx2. Okay, remember you only need the sign. You are not bothered about anything else. Into the ddx of this will be what? 4xp minus x to the power of 4 minus 4s square into the ddx of the denominator. What is the ddx of the denominator? It is 1 by 2 root x to the power of 8 plus 4x to the power of 4 s square into the ddx of whatever is within. What is within? If you differentiate within the radical, you get 8x to the power of 7 plus 16 s square x cube whole divided by root over of x to the power of 8 plus 4x to the power of 4 s square. Okay. Now see, at x is equal to root 2s, what happens? At x is equal to root 2s, check the sign. Here if you put x is equal to root 2s, this is always positive, right? Right or wrong?
Yes, sir. Yes, sir.
This will be positive.
Yes, sir.
So that means this entire term is positive,
Yes, sir.
right? Next, if you put here x is equal to root 2s, then what will happen? This will become 0, right?
Yes, sir.
It will become 0 or not? X to the power of 4 minus 4s square. If you put x is equal to root 2s, this part will become 0. See, if x is equal to root 2s, just a little rough work. If x is equal to root 2s, then what is it? X square. X square is 2s, right? What is x
Yes,
to the
sir.
power
Yes,
of
sir.
4? It
Yes,
is
sir.
4s square. That means this part, x to the power of 4 minus 4s square will become 4s square minus 4s square.
0.
0. So
Yes,
that
sir.
means if this
0.
becomes 0, this entire part becomes 0, right? And in the denominator
Yes, sir.
also, denominator is also positive, right? That means at x is equal to root 2s, what is the sign of d2l dx2?
Yes, sir.
What is the sign? This is positive, this is 0, this is positive. That means this entire thing has to be positive. Yes,
Yes, sir.
this entire thing has to be positive
Yes, sir.
Yes, sir.
because this is positive, this part is
Yes, sir.
entirely 0, and this part is positive. Then positive by a positive has to be positive. Finished. So don't be afraid of differentiation. Okay, you just need the sign. So what happens? At x is equal to root 2s,
Okay, sir.
at x is equal to root 2s, which one is minimum? Length of the hypotenuse, right? L is minimum,
Yes, sir.
right? Now we need to find out the corresponding value of y. How will I find out the corresponding value of y? You put it here. Y is equal to 2s by x in the auxiliary function. Therefore, y is equal to what here? 2s by x. 2s
Yes, sir.
by x. That means 2s by x is root 2s. Now 2s can be written as root 2s into root 2s. Root 2s. So this will cancel.
Yes,
So
sir.
what is the value of
Yes,
y
sir.
that you are getting? You are getting
Root
y also
2s.
equal to root 2s. That means Therefore, x is equal to y is equal to root 2s. Therefore, triangle
Yes, sir.
ABC is isosceles, right?
Yes, sir.
Because triangle ABC is isosceles when the length of hypotenuse L is minimum.
Okay, sir.
So that's it. Okay, these are all applied problems. Now, one applied problem from your 3 dimensions relating to your cylinder and cones. Okay. This one, see this one. I'll work this out in a very simple way. They have taken all the angles and all. You don't need to take all these angles. The question here is, show that the height of a cylinder of greatest volume. You have only 5 minutes left. Would you like to continue this class till I finish?